Welcome back to Point of View, the session where we don't just learn English, we expand our perspectives on complex global issues through the lens of advanced linguistics. Today, we are overturning a massive climate assumption. If I ask you to close your eyes and imagine the planet's primary natural carbon reservoir, what do you see? I'm almost certain you visualize the dense canopy of the Amazon rainforest. This is what we call the arboreal consensus. We are conditioned to think that carbon storage must be synonymous with giant trees. For example, when discussing climate mitigation, politicians and media outlets focus almost exclusively on reforestation of tropical forests. We accept that there is no alternative to this view. But, just as we use the structure "there be" to describe existence in simple terms, science constantly updates what we know exists. While tropical forests like the Amazon are indeed key allies, a groundbreaking study published in early March in the scientific journal New Phytologist has revealed a paradigm-shifting reality. Our focus has been too high. We needed to look down. This study shows that unassuming wetlands in Brazil's Cerrado biome, a savanna known more for dry brush than lush ecosystems, can store approximately 1,200 metric tons of carbon per hectare. When you compare this to the Amazon's average carbon density, the figures are staggering. The Cerrado wetlands store up to 6 times more carbon. We are talking about a massive, largely unknown carbon stockpile hidden beneath the surface of what many consider a secondary biome. Today, we will dissect this study, understand the linguistics of environmental reporting, and analyze the profound climate risks posed by the ongoing degradation of this vital yet overlooked ecosystem. To understand the scope of this discovery, we must first analyze why previous data was so misleading. The research, led by ecologist Larissa Verona, in partnership with distinguished scientists from institutions like Unicamp and the Carey Institute of Ecosystem Studies, didn't just guess, they dug. For years, assessments of soil carbon stocks were superficial. Prior studies typically only examined the surface layers, analyzing soil samples from just 20 centimeters to maybe a meter deep. Imagine trying to evaluate the value of an ancient library by only looking at the books on the bottom shelf. The reasoning for this shallow approach was multifaceted: ease of access, lack of appropriate technology for remote areas, and an inherent bias that deep soil must have minimal carbon accumulation. Because researchers weren't looking deep, their initial results underestimated total carbon by a crippling 95%. They reported only what they saw on the surface, just as a beginning English learner might only use "there is" for present tense, missing the rich capability of "there might have been" or "there will be." Verona's team, however, collected soil samples from depths of up to 4 meters. They penetrated the rich, waterlogged earth of the Veredas, the iconic palm swamp wetlands of the Cerrado. This deep-core sampling revealed a treasure trove of ancient carbon that had been systematically accumulated over millennia. By failing to account for this depth, previous environmental policies were operating with dangerously incomplete data, essentially ignoring a ticking climate bomb simply because they hadn't bothered to look past the topsoil. We must ask ourselves, how is this storage possible? This is where the linguistics of biology becomes fascinating. Many people associate the Cerrado with dryness, yet these specific wetlands operate on a unique hydrological principle. Expert Amy Zan, a co-author of the study, provides the linguistic and biological key. Humid conditions of the wetlands cause a lack of oxygen. In scientific terms, these are often hypoxic or anaerobic environments. This lack of oxygen is crucial. It drastically slows down the decomposition of plants and other debris. In a forest, when a leaf falls, it decomposes quickly, releasing its carbon back into the atmosphere or topsoil. However, in these oxygen-starved Cerrado wetlands, organic matter accumulates over time instead of decaying. It becomes waterlogged and compressed, forming thick layers of a soil known as peat. The study applied radiocarbon dating tests to this organic material, revealing a profound timescale. The carbon present in these soils has an average age of about 11,000 years, with some records dating back more than 20,000 years. This is not a forest that there will be next year. This is carbon that has been sequestered since the end of the last ice age. Think about the implications of that timescale. Larissa Verona emphasized this critical point. If it is lost, we cannot quickly rebuild it, as is the case with a forest that can be replanted. Replanting trees takes decades. Replacing these peatlands takes millennia. There is no technological quick fix for the loss of 20,000 years of accumulated carbon. Despite this immense significance, the Cerrado faces an existential threat that is often obscured by our focus on the Amazon. The biome covers approximately 26% of Brazil's territory, the second largest in South America. It is the world's most biodiverse savanna and serves as the water tower for 2/3 of Brazil's major river basins, which eventually feed into the Amazon itself. It is a vital artery of the entire continent's hydrological system. Yet, Brazil operates under a flawed binary view of conservation, often described by a powerful linguistic metaphor. Verona uses it when she says, "We call the Cerrado a sacrificial biome." What does this mean? It implies that Brazil has historically prioritized the protection of the Amazon to placate the international community, but has sacrificed the Cerrado to maintain agricultural expansion and commodity production. Large-scale agribusiness, particularly soybean and livestock farming, advances over the Cerrado at an alarming rate. This agricultural expansion is not just about clearing land. It involves a fundamental, irreversible alteration of the landscape. The core issue is water. Agribusiness requires the drainage of wetlands and the withdrawal of water for massive irrigation projects. When this hydrological balance is destroyed, the carbon bombs are armed. The degradation of these wetlands is not a passive loss. It is an active climate assault. The researchers warn us about what happens when the logic of oxygen deficiency is inverted. When the logic is to use the Cerrado for farming, the priority is to dry out the soil. Drainage channels are dug and water tables drop. As the soil dries out, oxygen penetrates the deep layers of peat. This causes the massive accumulation of organic matter to decompose rapidly, millennia of buildup turning into atmosphere-altering gases in a few short years. The stored carbon is converted directly into carbon dioxide and methane, gases known for their high global warming potential. Professor Rafael Oliveira from Unicamp used a powerful, terrifying metaphor to describe this. We'll be unleashing carbon bombs into the atmosphere. The quantity of organic carbon previously unknown, covering a vast area, could, if released, negate all other climate mitigation efforts in the Amazon. Moreover, the risk is amplified by seasonality. Measurements taken by the team indicate that about 70% of the annual greenhouse gas emissions from these ecosystems already occur during the dry season. This is the period when the soil naturally loses moisture and decomposition accelerates. Climate models predict higher temperatures and longer dry periods in the coming years due to global climate change. These environmental trends will further exacerbate the drying of the wetlands, meaning there will be more carbon released even without direct human intervention, creating a destructive feedback loop. In conclusion, the study in New Phytologist has provided us with a crucial point-of-view adjustment. It has proven that the Cerrado's climate importance is vastly underestimated. This massive hidden carbon stock is not usually included in climate calculations. If we can't measure it, we can't manage it. Now there is data. Now we must have action. The current strategy of treating the Cerrado as a sacrificial biome to protect the Amazon is untenable. They are hydrologically and atmospheric interdependent. Draining the Cerrado to farm soybeans while trying to save the Amazon is fundamentally illogical. The researchers advocate for immediate and expanded protection of these specific wetland areas. We need greater recognition of their role in climate stability. While some Brazilian legislation calls for the protection of these environments, the lack of enforcement is critical. Researchers estimate that up to half of these irreplaceable areas have already suffered some form of degradation. We must shift from a narrow, Amazon-centric vision to a holistic understanding of biomes. There must be a new conservation paradigm. We must protect the 20,000-year-old reservoirs beneath our feet with the same urgency that we protect the canopy above. If we fail, the carbon bomb we only just discovered will surely detonate. Thank you for listening. Keep listening, keep analyzing, and keep refining your own point of view.